especially Sweden a lot. But we are also present in Belgium, in Germany, and now we are also doing more and more activities in Italy in that way. And much more, but okay, that's not the purpose. But I mean, we are not only providing BESS for Sweden. This is the kind of message that I want to say. So yeah, that's the point. So maybe my colleague Frédéric can
Yes.
present himself now.
Yes, Frederic. I do not speak French. I stick to English and when needed Swedish. But yes, I also work with Frederic. I am not as technically savant and knowledgeable as he is, but my job is rather to ensure the overarching functionality in terms of delivering the product and services, to ensure that we have the BMS is working with the battery and with the EMS and everything, and more on a management level than technical. But having said that, I do have a deep technical interest and is quite curious about this. So.
All right, perfect. I also invited Julien Fernandez, who is my colleague. He is in charge, in fact, of the project, of the BETSense project, especially at this moment, the certification according to the IEC 61508, which is a functional safety. I'm the manager of the company, so I don't have a deep background of the BMS. I know it a bit because I was during the initiation of the project together with Vito. We know Vito because we were working on a previous project which was called CellSense, in which we were, how can I say, monitoring cells of hydrogen, so for CVMs. And they asked us, okay, are you willing to work with us and to distribute our products about BETSense? And we said, okay, that can be interesting as well. Renewable energies is something that is quite important for us.
Mm-hmm.
So we are a small company. We are about 30 persons. We work from Belgium, but we have customers worldwide, or our customers sell worldwide. So in the domains in which we work in energy, we work in automotive, we work in medical sector, we work in railway sector. We work in quite specialized sectors, quite broad, but just to give you an idea of the type of customers we work with.
And are you familiar with BESS then?
To be honest, no. I know a bit of it, but we learn it. So I think if we need support, Vito is behind us and can help us. We are there for the BETSense product, so we can. We are also engineers and designing products. So I wouldn't say we are not agnostic to those technologies.
Okay. I have, of course, a lot of questions, but maybe we should first to present Julien, to be polite, and then I will ask a lot of questions after.
Okay, all right.
So hello, I'm Julien. So I'm part, like Mike said, to the development team here in DVC, and I'm in charge of the project BETSense to try to have the seal 2 of the norm IEC 50508. In DVC, I'm also in charge of all project with a line of cobot with lot production. So we are doing BNR software and also that.
Okay. Okay. Then I come back a bit to you, Marek, to understand quite well I will say DVC position and Vito, because when I was in contact with Vito, or at least I came in contact with Vito, I understood that they were quite, I don't know if I can say specialized, but at least I understood that they have already developed BMS for BESS activities. Is
That's
that correct? Or,
That's
okay.
correct. Yeah, absolutely.
Okay. So what is then, why are we then in contact with you and not with Vito?
Because we are, in fact, the company will provide you the technical support about this this BMS. If, for example, you have a new kind of new technology of battery that you would like to try, they will help us to put this in a model. So they have the test facilities that we don't have. But regarding the electronics for the BMS, we have the full access to it. We have the know-how about it. So we, in fact, what we did, because it's a research institute, Vito. So what we did make it more manufacturable.
Yeah.
So
Yeah,
we improved the manufacturing.
Yeah.
Yeah,
Okay.
absolutely. That's so that's what we stand for. So we probably won't be able to answer you all because they made the development, but all the questions, they will be answered.
Yeah. Yeah.
Because our knowledge also increases with all the questions that we get from customers.
Okay, good. So if I understand that well, they have probably then, I will say, developed different level of architectures of BMS for BESS. I will ask more technical details of that, but at least they have already developed something.
They have developed, and it is already running. They have some sites where it is implemented. The main advantage of the system is that it is rather flexible. There are a lot of parameters that you can adjust. The system is also, well, they call it, it's not a low-level BMS. They can do a lot of things. So just to give you an example, we can adjust. So in fact, I will say it otherwise. We try to optimize the use of the battery by allowing the batteries to get the most of their energy storage at the top. So when you do charge, we go because normally in most of the systems they stop when a level is reached. We will adjust so that the weakest battery also reaches the highest point. And we do exactly the same when discharging the batteries. We will put energy in the weakest batteries so that we can go that we can get more out of your battery system. They made simulations, and they claim that they can reach up to 10% more battery capacity than with a normal BMS system.
Do you mean here what you are explaining to me, the active balancing instead of passive balancing?
Absolutely.
Yeah. So okay, so it is a BMS that they have developed in active balancing, then, if I understand.
No, absolutely.
Yeah. Okay. So why we are contacting you to make you a bit a kind of vision. So Spark is, like I said, a BESS company. We are also not a huge company. We are not a cartel or whatever. So it's a smaller company, but we do from CNI to high utilities BESS. But we currently, I will say, we focus under 20 megawatts, something like that. If we want to go more, why not? But we are in that kind of level situation, not so high, like 100 megawatt projects, things like that. So that's not directly our purpose. We are too small for that.
Okay.
And but the particularity of Spark is that we are listening to the client. The client say, okay, I have this power as need and this capacity as need, and we customized, if I can say that, the BESS. So we develop from the design till the commissioning, till EPC, so that we take care of everything about the project for the installation, the grid installation, connection, aggregator, because we have also our own EMS in that way. Okay. Today, so we are working, I will say, in different situations. I will say in terms of batteries, we have a partnership in China. Okay. And this partnership is doing the battery modules in China, including, I will say, subcontractor BMS, which I'm probably sure that you know them. It's BMSer. So BMSer is, I think, number 2 in BMS supplier in BESS. Okay.
Okay.
So that's the situation. We have also another, I will say, situation, which we have also. We are beginning to have a battery supplier here in Europe, but I don't think so that it will be the solution in long term. Why? Because what we are looking for today, we are studying the situation that instead to do the battery modules in China with our partner, we do the battery modules here in Europe by the integration of, I will say, a much more, I will say, confident BMS chosen by us, by Spark.
Just one thing, Frederick, because you said that your battery supplier in Europe and the assembling it in Europe was not the long term.
No.
But and then you say you will work in Europe, and there I don't get the difference.
The supplier, the battery supplier here in Europe is, I will say, a kind of fine, but we don't think that we want to be in long term still a supplier for. I mean that this company will be still a supplier for us. That we do ourselves our battery modules. That is the thing. So that means that we in the future, that we are not depending on a battery module supplier. I will say that in that way.
Okay.
But we
so
do still.
You would like to choose your batteries, your battery supplier. You would like to choose your BMS. So you want to have all flexibility.
We want to have like a kind of Spark battery module, I will say, which for sure, and then there, trust me, the cells will be still coming from China, because I don't see a cell manufacturer in Europe, at least not for BESS. And but the BMS we can choose. I mean, the BMS we can do something ourselves, and because we see that with the BMS coming from BMSer, for example, where we are completely dependent on them if they say, oh, I want to change that, we cannot see it because we cannot adjust. So we are completely dependent on them. So we really want to have something from us, and that we understand the situation, at least in that way. Okay.
Okay.
So that's the purpose. But again, it's a kind of study phase, etc. Because yeah, of course, we are not there yet. But it can be, that kind of decision can be quite quick in that way. And so that's the reason why we are looking to a potential BMS supplier made in Europe by preference. Because, of course, when you write to someone, yeah, it is made in Europe, well, it is directly a kind of more trust situation instead of made in China every time. Also, some clients, companies, they say, no, made in China, no way, due to cyber security, etc. So it is something like that. So that's one of the reasons why we are looking more in BMS European in that way. In terms of chemistry, we are only using LFP.
Okay.
Okay. So I think that's kind of important situation for your BMS.
Well, not really, because in fact you can choose a chemistry, because in fact it's a model. So it's you can even so we have two strings that we can control, and you can even change the chemistry in the two chains. For example,
Okay.
they made tests for that was for how do you call that, buses, and one of the chain was done with supercaps, and the other was also with LFP batteries, and because they needed the regeneration when the engine was braking, and then they charged supercaps, which was more interesting in that case.
Yeah. Okay, but it's interesting. It's interesting because, of course, by today, LFP is one of the most interesting chemistry today, but I cannot tell what is the future next year or in 2 years, because it can be another chemistry will be there, and it will be more interesting.
That's the big advantage of of BATSense, so the system developed by Vito, because they are able to measure between 0 and 5 volts for each battery.
Cell, yeah.
So for each cell, so this means that it is even ready for sodium cells. Yeah. Because there they can discharge up to 0 volts.
Yeah, totally. Yeah, very good. Interesting. Good. So, and with this BMS from BMSer, it is 3 level of architectures. What does it mean, 3 level of architectures? It means that we have a battery module with different cells inside, and then a BMS in the battery module. Then we put several battery modules in series to make what we call a cluster or a string, depending the vocabulary of everyone. There, on the end of this, I will say, on this cluster, there is like a main, what we call a power distribution unit. So that is controlling all the different battery modules that are connected in series, which then there is a second level of BMS. Okay. And then we put different clusters in whatever situation, container, anyway, in parallel. And then we increase all this capacity, so it can be so many strings in parallel. And then we have like the third level of BMS that is controlling all the clusters.
Mhm.
Okay, so that's the situation. In terms of, I will say, first level of BMS, so that means that the BMS that is inside the battery module, it is what we call a slave BMS. A slave BMS means that is just reading information. Okay, reading information. Essentially, here is the temperature and the voltage in a tool.
Yep.
Then you have the second level of BMS that is in this power distribution unit on the top of the cluster, who is then controlling all the battery modules. So this is not anymore a slave, but a master BMS, because he has, if I can say, the kind of power to, if there is something wrong, well, he opened the circuit, for example, but he will also say, okay, he will read the information coming from the slave BMS of each one, and then he will say, okay, you are not happy because you have this state of charge or this level, things like that. So, I mean, he will already control all these battery modules. And then this third level of BMS, who is then reading all the information of everyone. He can still then read all the information of each cell, because it goes till there. But we connect also all, I will say, safeties, I will say, equipments like fire system or things like that, or the cooling system, that is say, but I see that the string number 3 is a bit more warmer or whatever. I need to control that the cooling or the heating needs to be done for that cluster. Or fire system, in case that something is going wrong, that he will activate, communicate with the fire system as well. But this third level of BMS will be also in connection with the PCS. So the PCS is the power conversion system, because he will give all the information to do the conversion from DC to AC. And this third level of BMS will be also in communication with our EMS, because from our EMS, we want to read what is the state of charge for this battery. I mean, we want to read everything from this BMS. So this is a bit, I will say, the architecture that we are doing by today. We are using passive balancing today. Okay. But we are very open to active balancing, of course, in that way, because, like you say, you are winning a bit in capacity. I mean, you can win some capacities from each one.
Absolutely, yeah.
So that's the situation today. So I don't know, is it something familiar what I'm explaining, or is it completely Chinese what I am explaining here?
No, it's totally we are totally familiar with this. So for us, when you spoke about the slave BMS, for us it's called a VBU. It's called a voltage balancing unit. This is also a slave device. So in fact, we work also in 3 levels. So you have each cell or each cell in parallel that will be monitored via this VBU. So each VBU circuit is able to, in standard, I will say, is able to control 4 cells. And then you can make a string out of it to go up to about 500 volt. So it will depend of the length of your string.
Then
This
I will interrupt you about
Yes.
this. I will say I have already forgotten the name of your BMS,
VBU.
the first level of BMS. I will say we have two types of battery modules. We have battery modules with 16 cells, and we have battery modules that can go to 52 cells. So the difference between the 16 cells is that it is a battery module that is air-cooled, okay? And
Yes.
the 52 cells is a battery module that is liquid-cooled, okay?
Okay. Yeah.
So I don't know, is that something also new, or do you have like two different first level of BMS?
No.
One more for
No.
so many cells, and then so many much more cells. I don't know, because it's
No, because in fact it's a daisy chain. So in fact you just select the number of VBUs you want.
okay.
So if you go in software, we can go up to 64 cells. So the software is foreseen up to 64 cells.
Yeah.
And wait, 64 cells, 64 VBUs. I'm sorry.
Okay.
So it is 250 cells, I think. But that's the maximum
For
because
one VBU, you mean?
no,
64 VBUs times 4 cells then.
yes.
Yeah, okay, yeah, okay, in that way, okay. Yeah,
Yep,
okay.
absolutely. So the 52 cells that you speak of, so this is something that we can do.
Yeah, totally. Okay.
Okay.
And then
yep.
your VBU, how many NTCs, for example, it has, because the NTC will take the temperature of the cell, will be the temperature of the cells of every two cells, or every cell can be connected with one NTC, or I mean, what
so
is a bit
every
the situation?
cell can be connected to an NTC.
Okay, super.
I don't say it,
wow.
and you can also put an NTC on the printed circuit board itself, so to have the overall temperature. But we have the possibility to have on each VBU board, so like I said, for 4 cells, to have 4 NTCs connected to it. So that's a configuration that you need to tell us when we produce.
Yeah. Good.
So each VBU circuit is connected to each other via 3 cables, but as I didn't say it, but we are designers. We are able to customize the products. So for one customer, we designed the board where the VBUs, where a couple of VBUs were integrated all together, so that you could gain in cabling.
Yeah. Okay.
Because otherwise you have to put cables. And so we can assemble boards up to 600 millimeters in length. So that to give you an idea. So if that could be more interesting for you, that is something that we definitely can do. Of course, we will. There will be design costs, or there will be minimum quantities, but it is possible. So it will be. We'll have to define it together. Is it worthwhile to do this? This modification? Well, in fact, it are just modules that we just have to copy paste. Julien will tell me that it should be like this, but it was not like this to copy paste. So we had some issues by doing that, but all right, that's the idea behind it. And so this string is controlled by a master circuit.
Yeah.
Okay,
and this is called master, or
it is called a master. Yes,
it's Mr. Master. Okay.
Yep.
Good.
And so you will have different strings that all will be connected to masters, and all those masters will be connected to a main master that will and this main master will aggregate all the information and this main master will also have the inputs and outputs. So, for example, to read the current through the charging current, for example, to and it will also be able to control the contactor, the fans, and so on. And all this is programmable. Vito has developed a matrix of things that you can change. So you can yourself change the logic of the BMS.
Yeah.
Well, to be honest, this makes it a bit more complicated to reach SIL2 level. So once you have defined how you want it to work, normally we propose to make a non-programmable version of that. So
Yeah.
during your test, you can do everything you want. Afterwards, we propose that you don't change it anymore.
Yeah. Okay. And for this main master, how many master can you connect?
Do you remember, Julien, how many masters that we were able to connect?
I'm looking to the documentation that I have done last week. So wait just 1 second.
I know at least 14, but I can.
That's what I have in mind. It was 14. So.
Okay, but at least minimum 14. I heard it already. That's good. And you can confirm that later. That's not.
Yes.
And then how do you? I will use the wording estimate the SOC.
How do we estimate the SOC? It's based on a Coulomb counter, if I'm not wrong.
Yes.
Okay. Yeah, but that's yeah. So you measure the current, and then by the current you estimate by Loi Coulomb, and yeah. Okay.
Yep.
Good.
Yep.
Okay. Yeah. Okay. Good. So at least this is what I want to. I'm testing you.
No, but I'm not completely.
I'm the master now.
I'm not completely familiar with the project, so I'm and it's a long time that I was not in this project, but I know it's a Coulomb counter, that's for sure.
No, okay.
Quick question.
Yeah.
What is the lowest current that you would pick up?
You are reading my things.
Yeah.
Okay. In fact, this will depend on the current sensor that you use, and Vito was proposing or is proposing to use. Do you remember the name, Julien? But the advantage of the current sensor that they propose is that it is dual range. So you have for the very low currents you can measure, but as well as for the high currents. But I can't remember. I can give you the reference if you want also after the meeting. But they have foreseen this so that you can measure as well very small currents.
Yeah, we
and I
should
don't think
yeah.
You want to know the resolution, in fact.
Yeah, at least. I mean, why this question? Because we have some experience in that way. That when you are reaching this, I will say, state of charge, so means low currents, things like that. So the BESS is acting, not really well. So that's the reason why the accuracy of the current is quite.
No.
I'm
pretty sure
to hear. Yeah.
I'm pretty sure that it's the first time also that Vito is launching alone in a meeting, so they could answer you very rapidly. But at a certain point, we have to also fly ourselves. So this time I will need to ask them and to write it down. But to range sensor. But Julien, you write those questions down and you will
Yes.
answer to Frederick?
Yes, I
Okay.
will send.
Okay.
Okay, good. Okay, yeah, so that's then you are on the master, and then you are on the main master in
Just one
that-
information more, Frederick, that I can tell you. I explained you that we can assemble the VBUs on one board. What we did for the customer was also to assemble the master, what we called, in fact, submaster on the same board, because this master is communicating with all the VBUs, and so this was way more convenient for that customer to reduce the connections between the slaves and the master. So he had also just two types of circuits. In fact, we call them submasters and one main master.
Yeah, okay. Okay, good. Okay. And in terms of communication, is it CAN or RS, or what kind of communication you are using between all of them?
We are
You know?
using, in fact, between the master and the slave, it's a special protocol. So we don't speak about this because this is proprietary. But between the masters themselves, we use CAN.
Yeah.
So each board has also two CAN buses, which allows to have the communication between the masters and one external CAN communication for you.
Okay.
And between the main master, is that also CAN, or is there any Modbus TCP connections, or?
Yeah, to go out. Yeah.
There is no Modbus TCP connection at this point, but there are, if you want, there are converters for that. If it's a blocking point, we have already experience with Modbus TCP, but the processor that is used at this moment, it's a special processor with redundancy. And this we didn't program Ethernet yet on this processor.
Okay. So that means that if we don't change anything, and the main master needs to be in contact, in communication with our EMS currently, this is also CAN.
Yes.
Currently.
Yes.
Okay.
That's not good.
Is that an issue for us?
I mean, it's not for this kind of decision. I mean, today we talk mainly over Modbus TCP.
Yeah.
But if we are to decide upon our own BMS, then we just develop.
There is some flexibilities.
Yeah. We can do that.
Okay.
That's something. In fact, I don't exclude anything, but this will take a bit of time due to this special microcontroller, as I said.
Yeah.
Maybe Julien, that's something that you can look at if for the processor, the Texas Instrument processor, or maybe we can do it otherwise. We will go to the supplier of our stack and see if this stack can be compiled on the Texas Instrument processor. I will put you in contact with Pierre, who knows more about this.
Okay.
So stack.
Then I will say this Vito BMS. When was it developed? How mature is the BMS? I will say it in that way.
It has been developed, I think, I would say 6-7 years ago. But
Okay.
but I will give you. I think it's even a bit more. But this is a figure that I can give you. We have to ask it to Vito as well.
Yeah,
I think it's a bit older than that.
And then for doing some adjustment or whatever, configuration settings, things like that, this is quite easily to do, or we need every time to come to you to?
No. The idea is that we give you full control to it. So there is a software which allows you to change
Yeah,
those parameters.
exactly. Yeah.
There is you can bootload the board as well.
Yeah.
Yourself. There is software foreseen. You you can implement the protocol yourself. And then there is a LabVIEW application where you can see everything working. So there
Yeah.
are different ways of getting access to those things. So
Yeah.
I would say it's not basic, but what is present gives you a good idea. But if you want to go, not to use that, then you have to program in Python or something like that.
Yeah. Understand.
There is also the libraries are also present to enable you to do it with a PLC, for example. The models are present, so it shouldn't be a huge problem for you to have it work.
Yeah.
I think that sounds very attainable and available.
Yeah. Sometimes we see best systems that, in fact, after your main master, there is again a new box, I will say like that. Very often they call it controller, which we combine, I will say, all the input coming from your main master and all the input from the PCS, and from that control box controller, we go to the EMS. Is that something familiar for you, or no? This is the first time that I hear that.
Well, can you, because that's just architecture, that's how you do it, I would say, because we have integrated, for me, the control is inside the master itself due to the programming. So that's like I said, maybe I answer, if you think I'm answering wrong, but according to me, this is included in the master. Because we have this configuration matrix, we control the fans with the master.
Yeah.
In fact, there are 8, well, it was at least 8 outputs and 8 inputs in which we can handle and have it working like you want. So if you want to have different relays, for example, to because you want to at the beginning to have a lower current, for example, those are things that are easily programmable within the BATSense. How they call it again? This matrix, this programming matrix.
Do you have like? Sorry, Julian, you go.
No, it was a LabVIEW program for the I/O matrix to see everything, the voltage cells. That's.
Yeah.
You have it on your PC. Can you show it, Julien?
I will look at it.
Or otherwise, what we can do is maybe foresee a second meeting where we can show you the tools that we have, because maybe it's a bit short notice here, and
we understand that. What I would be curious if there was like what do you call it? Like a structural mapping for us to gain understanding of, okay, where is the VBU and everything. That would be super helpful for us to.
Okay, in that case, I didn't know what was the.
No,
I was not prepared for this meeting.
But
so
again, it's a first meeting.
So
but what we could show you is the architecture. We could show you the boards. And maybe we could show you also the tools, the software that is available, and that will give you a better idea.
Definitely.
Just for information, maybe before that you are sharing something and on us, things like that, maybe we should to sign an NDA. I can send a layout of NDA if you want. I don't know if you are.
To be honest, Frederick, there is that much of efforts in the programming of this. I don't care. It's not important. At this point, we will not share critical information.
Okay.
Just
no
to
problem.
give you an idea, we are almost 1 year busy about the IEC 61508, this functional safety. So it seems easy. It is not, in fact.
Yeah. Okay. No problem. No problem. Frédéric, you did also the kind of specific certification for the EMS, but I don't remember which one.
That's
For
the
cybersecurity or something
yeah,
like that, no?
NIS 2, it's called European Security
Yes,
Standard. Yes.
CRA, you mean?
Yeah.
Cyber Resilience Act.
Exactly. Yeah, it's
Yeah.
called a little bit different, but yes, that's the one.
Yeah,
Are
because
you on
NIS
that level or not, or I don't know?
We are investigating this. I'm not able to tell you that we are, but
Okay.
because it's mandatory from 2027, if I'm not wrong.
Yeah.
But I will inquire about that.
It's
Yeah.
not necessarily. It depends a lot upon how big you are as a company and where you are. So it's more or less mandatory. But yeah.
It depends also, because normally if the port is accessible, indeed you need to. But if it's inside another equipment,
Yeah.
and that you cannot communicate directly with the CAN, it shouldn't be necessary, in my opinion.
I think you are correct, but I'm not gonna. I might be wrong, but yeah, I believe so.
I know things about this, but I'm not a specialist about this.
No.
Because we have to follow it up. For sure, if you want TCP, there it will be mandatory.
Yeah, that's.
Okay. And Julien had a question.
Yes, if you want, I can show you the LabVIEW, the iometric LabVIEW, and also the master and the configuration, if you want, right now.
Sure.
Just for your information, I'm expecting an expert because we were robbed here in the company, and so he's coming at 2:00. So when he's coming, I will have to leave this meeting. Right, so through 2 or 3 weeks ago, and they want to go for the expertise.
Yeah, of course. Sorry to hear that. Yeah, of course. Yeah.
Happens.
Did you see my screen?
Yes,
of the LabVIEW?
Yes, we do.
Okay, so here is the LabVIEW, or we can you can see. It's not connected. It's not connected at the moment, but you can see the logage of different information that you want. So, for example, here we have the cell voltage and the temperatures of the batteries. We can show the balancing status. We can equalizing all parameters that you can configure at the moment when we connect it to CAN. You have different nodes of the VBUs with the string. So there is all the information you can have, and we can add more if needed. You have also the different voltage of the one pack and the power also. That's information. You can configure directly if maybe you want directly configure just 6 VBUs instead of 10 in the string. You can directly connect it. If, for example, there is an issue with how to say that, with cables between VBUs, it will directly it will be skip the VBUs incorrect with the cable, but it continue with the other VBUs. So everything has logs. So
yeah, maybe that's something that we can also tell Julien, is there is a connectivity check. So Vito has developed a way to detect if a battery is connected or not. Because if you have 2 batteries and you measure and one is not connected, in fact you will measure with the system half of the voltage between the 2 cells. Well, Vito has developed an algorithm to be able to determine if it is the case or not. So if a cable is broken, it will be detected.
Yeah.
This is one of the security measures that is in place on this BMS.
And does it mean in terms of, like you said, this connection, in case that the connection is there but weak, means that there is a high resistivity or something like that. Is that something that he can detect instead by voltage?
It will be depending on the resistivity. Of course, if it is, I guess 1K, for example, we will probably not detect it. But if it is higher impedance, we can also ask this from which impedance on we detect it. This is something I don't know. It's quite technical, but we can ask this.
Yeah. Okay.
So wait, and so connectivity check. Check.
Okay, looks good. Yeah, time is running, but at least I think we have a kind of good vision.
I think so.
on
For a first meeting, this is good. There are some
nice.
parts that I find to be quite interesting, not the least the capacity for us to work together in terms of software development and then set a configuration which we then lock in and make unchangeable. I really like that.
And the BMS is made in Belgium?
Yes.
Or in another country?
No. We produce at our company here in Nivelles.
Yeah.
So everything is done
in Nivelles. Okay.
In Nivelles.
Okay. Yeah. Okay.
No, so it's we are 20 kilometers south of Brussels. So here you see, Julia is presenting you the board, the main board.
Mm-hmm.
So we don't have the dimensions, but I can. I will pick.
Yeah.
I will pick up one.
I have here the dimension here. Sorry, it's another screen.
Yeah.
You see the dimension. Just the connectivity are there in this file. I need to make one file to have anything.
Yeah.
I will show you. I will show you the boards. So here you can see the boards. Yeah, I will have to shut down the filter if I'm able to do that.
But it was okay. It was okay. You saw it.
Wait. Okay. No, okay. Like this, you should see it better.
Yeah.
Okay, and this is the VBU. So for 4 cells.
4 cells. Yeah.
So here you have the inputs of the connection to the other VBU or to the master, and there you go to the other VBUs.
And that will be in a kind of casing box?
We can, but normally not. That's something that we leave up to you. But if you want, we can speak. This is something that can be discussed.
Or there will be like a protection film? I don't know.
Yeah, conformal coating. You mean?
Yeah.
We can do conformal coating.
Okay. Yeah.
So we can 3D print housings, but it's the first time. But normally people they assemble it themselves, and they foresee. So everybody has his own demands. So we can foresee if it is needed for you, but it will be depending again on the quantities.
Yeah.
But conformal coating is for sure not an issue.
Okay. Okay, good.
All right.
I see but yeah, that's.
Yeah.
I will I have still a lot of questions, but yeah, for a first stage, I think we have at least a good view
ID. Yeah.
on exact
Yeah.
in
What
in
I
that way.
propose,
Very
what I
interesting.
propose, if you're interested, what we can do is send your questions. We will answer them. And what I propose is maybe to make you a better demo about the software when things are connected to it. For sure, we will answer you. I'm just going through. So confirming that's sorry, the state of charge is done by a Coulomb counter. We will answer you about resolution of the current sensing.
Accuracy,
We will look about the TCP/IP stack if we can put it on the TI processor.
To have a kind of overview, I mean, like a diagram, something like that.
Okay.
What you like the VBU
about the architecture diagram.
Yeah, the architecture. Exactly. And I don't know. Do you have a data sheet or something like that of each element or not?
We should have. And that's something that Julien will provide you as well.
Okay, good.
So, no, in fact, we have it because it's part of the IEC 61508 documentation that we have.
Okay.
But maybe we can see. I will see with Vito if we can share or what's. Oh, but there are things we can share with you. But you didn't receive anything from Vito up till now?
No, from Vito only one email that says please contact Marek Vertongen.
Okay, it's okay. No, because before all the contacts we got from them before, they were already in discussion with them, and they had gotten the documentation and so on. So, okay, so this is something that I will clear out with Vito because they didn't inform about the fact that
but it's not a problem in any way.
It's Okay. I mean that's I understand, and again, I think it was last Friday or something like that. I've just sent them, okay, we are interested. So the reaction is quite quick, I will say, which we already appreciate the situation. Okay.
Okay, but we were not prepared for that. To be honest, I thought they had told you more. So okay.
So, but again, if there is some issue for sharing situation, etc., currently we can sign an NDA if you feel that an NDA needs to be done. No problem for us. Absolutely no problem.
I will ask to Vito, but I'm almost sure there is a commercial documentation that we can share with you. If it is more deep, I'm almost sure not, but I will ask them because they are the owner of the IP, so I have to be careful.
That's good. All right.
Okay.
I have a follow-up meeting
here, but I'm a bit sorry that we were not well prepared, but we will try to answer you better.
We got good
answers.
Okay.
It's okay.
Okay. All right.
Thank
gentlemen.
you so much.
Thank you.
Thank you, and have a nice day. Thank you.